Hey, everybody. So today I have a really fascinating interview with Jeff Dean, who's one of really a software engineering legend who's responsible for helping Google really scale up their workloads and distribute them. And he sits down on the Google X, I believe it's called the Moonshot podcast. Yep. And they talk about the origin of Google Brain. And so, one of the things I'm doing on this channel is anytime I see an AI interview that I think is meaningful, I like to give my commentary on it. Um, and another item I want to touch on in this video is uh, really talk about how OpenAI was able to commercialize AI and really get first movers advantage in the market and really capture the consumer market with AI. So first, we'll get into this interview, talk about Google Brain and how Google Brain started. And then we'll talk about OpenAI and how they were able to commercialize faster than Google and beat them to the market.
Up to here? And he's like, oh, I don't know yet. But my students at Stanford are starting to get interesting results on neural networks with, speech and vision-y kind of applications. I'm like, oh, really? I like neural networks.
So Google X is really a separate entity from Google, and Google X is sort of like an incubator where they're looking for 10x ideas. So not incremental progress, but really trying to find technology that is really new discoveries, right? And technology that has the potential and has big market, right? So Google X, I guess initially was approached by a professor from Stanford, I believe Andrew Ng, and Andrew had been working on neural nets. And at Stanford, I guess they didn't have access to a ton of compute. So, but Andrew Ng and some of these students at Stanford, had a hunch that if you scaled up the compute on these neural nets, they would get a lot more intelligent quickly, right? And so they approached Google X, and really what I want to say here is that what's interesting is a lot of these ideas are born out of academia, and and what's interesting is in academia usually they're using open source models, right? And and I'm not sure, I don't have any exact details on this, but it's my understanding that a lot of in a lot of academia settings they're using actually DeepSeek, Chinese models, because they're really at the frontier of open source. But anyway, so this idea was born out of Stanford, and then they started looking at this idea at Google X.
We should train really big ones. And so that was kind of the genesis of the Google Brain team was, hey, let's see if we can really scale up neural networks. Now that Andrew and his students had started to see, and others had started to see good results on using GPUs, Moore's law had advanced in 20 years and given us way more compute. Google had a lot of computers in our data centers. So I said, well, let's just do a distributed neural network training system that we can train very, very large networks. So we trained, on 2,000 computers, 16,000 cores using CPUs because we didn't actually have GPUs in our data centers at the time. And
so these models, again, they have attention layers, right? And at a very high level, really each attention layer pays attention to certain aspects of the sentence or certain aspects of the tokens, right? And so they're running in really like a parallel setup where you have many different machines, and each one of these attention layers is on a different machine, right? And that's where he's talking about parallelism, right? And so breaking out these attention layers and really distributing them across many different machines, and then feeding a lot of data into that.
said, let's see what we can train. And gradually more and more people started working.
Now, what's interesting, and he'll get into it, but this happened in, this was 2011, right? So I guess the students were running on GPUs already. I'm not sure how much of the NVIDIA framework was built out at that time. Um, and at this point, we know that the GPU is the right hardware for the workload, but I guess in 2011, Google decided, okay, we have CPUs in our data centers. Let's go ahead and since we're just testing to see if when we scale the model will get more intelligent, let's just go ahead and distribute this workload on the CPUs.
On the project,
Not knowing maybe that at the time the CPUs weren't the right workload for, or weren't the right was not the right hardware for the workload.
we trained, large unsupervised models for vision. We trained a bunch of supervised models for speech. Did a bunch of stuff with collaborating with, search and ads and various other parts of Google. Eventually, we had hundreds and hundreds of teams using neural networks based on the kind of like early framework that we sort of started putting together with just.
So again, so in 2011, Google was aware of this technology. They had built neural nets. They had distributed them internally. And they really, I guess, had a research mindset at this point. They knew, I guess they had scaled it up and they were testing it internally. So what's interesting is that, this technology has been around for a while. Now, maybe the scaling laws weren't here yet, but Google, I guess, had this tech in-house, or they were aware of this technology, and scaling it up made it more intelligent.
A handful of people.
And so the question is, why didn't Google commercialize it, right? And that's why, well, we'll get into that in a bit here.
Yeah. So when Andrew was in that chair talking to me about it, his description was almost exactly what you said, except with a much higher degree of needing you. So his description was, I had this secret data, which wasn't at all secret. It's just no one would believe me, that the size of the neural net mattered, that if you just like kept making it bigger, it just kept getting better.
Yeah.
That we knew from my students at Stanford.
So again, we've known this since 2011, which is interesting.
The thing we didn't have was Jeff. What we needed to do was make this attractive enough to Jeff that 1 + 1 could equal like 100,000 here, because I think they understood that this was going to take a sort of spanner and MapReduce kind of mentality, the ability.
They didn't have they knew they needed to compute, right? And they knew Google had the infrastructure and the talent to maybe help bring this to market.
To do this at such a scale that it wasn't going to fit on a single computer, the kind of thing that they don't teach you in academia how to do.
Yes.
So one of the things which I think in the early days we thought was going to be important, but maybe mattered a bit less, was the MapReduce part of it, the break up the problem part. Did that turn out to be really critical or less critical than you thought? As you started getting into like training these huge networks?
Yeah, it turned out to be quite important. I think we in the early days of the Brain team,
So Jeff Dean, again, he was responsible for helping Google really scale their operations, is my understanding. I don't know the exact details, but I know that he has deep understanding of really, like distributing workloads and managing that at scale. And so they're talking about, hey, how important was that knowledge, and how much of that knowledge translated to, I guess, running these AI models in these parallelism, right? Or running them in kind of these parallel systems where the layers of the model, and each layer is looking at different parts of the sentence, right? Maybe one layer is looking at grammar. Another layer is looking at punctuation. Another layer is looking at common phrases or common words, right? And so they take these layers and they distribute them across the compute.
Again, saw those results where you scale up the model, you scale up the amount of data you train on, the amount of compute you put into training, and the results just get better. So like we had a saying, bigger model, more data. And, these days that's been sort of more quant.
And so, that's the talk right now, right? Bigger model, more data, scale up. And now they've built these scaling laws, and you're seeing, they're building out the data centers, and we're on this mission, right? But why didn't, I guess, what happened? Because we were, this Google understood what this tech was in 2011, but we didn't get ChatGPT until 2026. As the average consumer, we didn't have access to this until now, and I guess that's what this video is really about. Is how was OpenAI able to commercialize faster?
Justifiably established with things that are called scaling laws, where people have observed, if you double the amount of compute, then you get better results by a certain amount. And it's got this really nice log linear relationship. Log linear is not as amazing as linear, but still, if you make your model bigger and train it on more data, you generally see better results. And so that's why there's like this wave of excitement happening now that is really kind of the continuation of that scaling trend. But what we built in the earliest days of the Brain team was a framework that would let us do both model parallelism, where you take a large model and you break it down so that pieces of it are on different computers. And at that time, our networks were not super speedy because it was basically data center and Ethernet connect.
So now he's starting to talk about really the framework, or the, I guess, orchestration layer, right, to allow the workload to run in this certain setup that was advantageous for the model to I guess, converge.
But to get a very large model training effectively, you wanted to parallelize it across multiple machines. And we actually would have different model architectures that tried to have relatively small amounts of bandwidth going between different pieces of the.
And that's why that networking, I guess, infrastructure, and I've heard the NVIDIA CEO talk about this, but, I guess that networking between the machines, especially when you get one layer on one machine and another layer on another machine, how fast those machines can talk to each other, I think is very important.
The model. So you might put like different neural network layers on different machines, and then not have to send all the state for a particular layer to all the machines.
How much did you think about the topology in the early days? I mean, you were all of a sudden trying to do something that was hundreds, tens of thousands after a year or two times bigger than anyone had ever built a neural network before.
Yeah.
Did you just like literally multiply, the width and the depth by 100? I mean, I know you didn't, but like unpack a little bit how you thought about what it meant to make something 10,000 times bigger.
Yeah. So I guess we made a neural network that was 100 times bigger in terms of number of parameters, and the amount of compute put into it was probably way more than that.
So they had a pretty big model, in 2011.
For what anyone had trained at that time. This was like 2011, early 2012. It was like a 2 billion parameter convolution, non-convolutional, but localized receptive field computer vision model. And so the way we did this was we essentially chopped the model in the X and Y dimensions, looking down.
And he's about to discuss right now about how they distributed these model attention layers.
The model. So the layers would mostly be on one machine as you went up in the layers for receptive fields that were small, looking at the bottom right corner of the image. And then another machine would be looking at the bottom left corner of the image, and go up the layers of the stack. I think it was like 9 layers deep. But you still need to send some information across from the bottom right one to the one just one to the left of that. And so it was like a 13 by 13 grid of machines for each copy of the model. And
so there's frameworks that they're building around this orchestration, right? And this is similar to kind of what NVIDIA does, right? And so NVIDIA is building these frameworks to handle the parallelism, right? And so you can, which is really, they really designed this specifically for this type of workload. And so, NVIDIA really accelerated the engineering on that. And so Google kind of kept this internally, but NVIDIA really opened it up. And that's my understanding. And I'll just go ahead and get into, I guess, so why did OpenAI, why were they able to commercialize faster? So I guess a few things. Initially, Google really had a research mindset, right? And they also had a search business that was highly profitable, right? And so, um, and also the technology was early, so there was safety concerns, right? So kind of a combination of some safety concerns. There's this research mindset where we want to continue contributing and publishing research papers, but then we also have this search business that we wanted to protect, right? And now I'm going to get into so here comes Sam Altman and Elon, right? And these are really the guys that did the early recruiting of bringing over some of the key people from this Google team, right, over to OpenAI with more, and OpenAI really had a focus on, let's build products, right, and try to commercialize this and bring it to market faster, right? And so I'm going to go ahead and jump into a really cool clip from Lex Fridman talking about a disagreement that Elon had with Larry Page. And this is when Elon, I guess, initially invested into OpenAI and started having some discussions about AI tech.
Prime mover behind OpenAI in the sense that it was created because of discussions that I had with Larry Page back when he and I were friends, and I'd stay at his house and talk to him about AI safety, and Larry did not care about AI safety, or at least at the time he didn't. And at one point he called me a speciesist for being pro-human, and I'm like, well, what team are you on, Larry? You're on Team Robot, to be clear. And I'm like,
and this is what's interesting, though, and this is what confuses me a little, is if Google DeepMind, had this tech in 2011, Google could have commercialized this, but they were, I guess my understanding is Google didn't commercialize it and distribute it to the consumer because they were concerned about safety. So this is where Elon has this story where he says that Larry Page called him a speciesist, right? And so he's saying Larry Page, I guess Elon was talking safety, and Larry thought that, hey, maybe this model one day will have a consciousness just like I guess this model might have a consciousness and become very human-like, right? So why do you care so much about the human species? You need to be equal and fair to the model. And so that's what Elon's story about. This is how OpenAI was born, on the premise of safety, right? And this is when they started trying to recruit the people from Google DeepMind.
okay, so at the time, Google had acquired DeepMind. They had probably 2/3 of all AI research, probably 2/3 of all the AI researchers in the world.
Mm-hmm.
They had basically infinite money and compute. And the guy in charge, Larry Page, did not care about safety and even yelled at me, and called me a speciesist as being pro-human.
So I don't know if you know this
then,
about humans. They can change their mind, and maybe you and Larry Page can be friends once more.
I'd like to be friends with Larry again.
So really, I'm going to go ahead and wrap the video here. I don't want to go too much longer, past 20 minutes. But so how was OpenAI able to commercialize faster? They essentially they recruited a lot of the scientists on the premise that, hey, safety, we're building safe, open models, right? And they built products faster. They built on top of the NVIDIA framework more aggressively, and they started running that workload on the GPU immediately. I guess Google was still running on CPU, but OpenAI made that decision quickly. But then at some point, OpenAI decides to become a closed source for maximum profit company, and this is when, so the story goes, this is when Elon parts ways, and because he wants to build open and safe models. So guys, I'm going to end it here. That's just my high level commentary on these interviews here. If you're interested, or if you like this content, please like and subscribe. If you're interested in more like high level AI discussion, you can check out my other commentary on other interviews. If you're interested in learning how to vibe code, you can check out my vibe coding live streams where I'm vibe coding B2B apps live. Thanks.